Hey, this is Alex Botmation Rising. Today I want to show you how to create your own multi-language Google Home Assistant that's capable of speaking 10 different languages simultaneously using the Raspberry Pi and Python. So what makes this great is that I can use my own custom wake words and also have Google give me custom responses. So rather than saying hey and the word Google, I could have it say, like Spanish to give me a Spanish interaction with Google, and also in response, the Spanish Google can then give me a custom response in its own language. So I also want to show you a short demonstration of what this is capable of. And if you're really interested, I have another full video just dedicated to a demonstration separately from this video. So let's take a look at the short demo. German.
Ja, Botation.
Hello.
Entschuldigung, ich weiß nicht, wie ich da helfen kann.
English.
Botmation ready.
How do you say can you laugh in Korean?
너 웃을 수 있어.
Korean.
안녕하십니까?
너 우인서.
죄송합니다. 어떻게 도와드려야 할지 잘 모르겠어요.
English.
Botmation ready.
How do you say do you have a sibling in Japanese?
あなたは兄弟を持っています。
Japanese.
おはようボットマチオン。
あなたは兄弟います。
こんにちは。アメリカ・ロサンゼルスで3月4日、日本時間では明日5日、映画界最高の名誉とされるアカデミー賞の授賞式が開かれます。今年はどんな作品が、そしてどなたが栄冠に輝くのでしょうか。
French.
Oui, Boimation.
Bonjour.
Bonjour Boatmation, ça fait plaisir de vous entendre. Il est minuit 52. La température à City est de 3 degrés et il y a un temps nuageux. Je vous souhaite une journée fantastique.
Australian.
Yes, Botmation.
Good morning.
Hi, Botmation. It is 12:59 a.m. It's currently 3 degrees and cloudy in our city. Today, it'll be sunny with a high of 9 degrees and a low of -3 degrees. Have a good day.
First thing you want to do is open up a web browser and search for Google Home Assistant Python SDK. And then you want to click on the link to Google's developer SDK file. In my case, it's the first result. This site was created by Google for potential developers like yourself on how to integrate a Google Home Assistant to your Raspberry Pi using Python. It's really a great place to start. There's a few examples in here where you can literally just do a hot word Google Assistant tutorial. So I'm going to walk you through on how to get yourself set up initially for your Raspberry Pi. So first thing you want to do is we're just going to basically check your hardware. We're going to go through the step-by-steps of what Google recommends in sequence. So first we're going to set up your hardware and network access. So let's go ahead and click on the link for setup hardware and network access. Here you'll see that Raspberry Pi 3 is selected, and it is recommended that you have a Raspberry Pi 3 Model B at a minimum. I have not tested this on anything less, so it's if you don't have one, I would recommend you get a Raspberry Pi 3 Model B just to stay on the same page as this video. You are also going to need a USB microphone. Raspberry Pi 3 does not have a audio jack input, so you're going to need to either go online and search for a USB microphone. Here they do provide a link for some suggested USB microphones. For what I used, I started using a very generic $5 USB microphone which just directly hooked into the Raspberry Pi. But however, I found that there was a lot of static in the recordings, so I recommend you get a dedicated USB sound card, which basically reduces the static a little bit, and then from there you can then hook up a audio jack into that sound card. It is also recommended to use a USB speaker. However, for my video, I used the 3.5mm jack right out of the Raspberry Pi. It worked as long as you had the volume up a little bit high. Any lower, you tend to get a lot of static coming out of the speaker. I am also using the generic Noobs install my SD card, so trying to keep everything as standard as possible. And lastly, if you prefer to use a USB keyboard and mouse and monitor to hook up directly to your Raspberry Pi, that's totally fine. For how I did it, I just decided to use a VNC session into my Raspberry Pi. For me, that's a little bit less setup, but yeah, you can basically choose however you want. Next is to make sure you have an internet connection, either through the Ethernet cable or through Wi-Fi, and make sure it works. And then once you have all that set up, we want to go ahead and click on Configure and Test Audio. So assuming that you have everything plugged in, what this next step is going to do is we're going to open up a command prompt, and we're going to type in record-l. And what this is going to give you is a list of microphone enabled devices on your Raspberry Pi, and you want to make note of the card and device number. Basically just write it down now for reference. In this case, my card is 1 with a device 0. Next is now we want to look for audio output speakers. Same thing, go back to command prompt. You can also click and copy if you like. Hit play-l, and this will give you a list of audio speaker devices that's available. What I'm going to do is use the generic Raspberry Pi device, which will be card 0, device 1. You can also see in my case a card 1, device 0, which is my USB audio output. But to keep things simple, I'm going to basically just use card 0, device 1, which is the Raspberry Pi default. So let's go ahead and write that down and make a note. Okay, and the next step is to create a new file named .asoundrc in the home directory of your Raspberry Pi. Just as before, they give you a pretty convenient copy button here. You can just copy the code, or if you like, you can feel free to type it up. And what this basically does is it sets up your microphone input and your speaker output into the Raspberry Pi database, so that it knows what you're trying to do when you launch the Google Assistant. So let's go ahead and create one. What you would do is basically right click on your folder and do create new, type in the name, .asoundrc. In my case, I already have one, so I'm going to hit cancel here. I'm going to open up mine. And here, my code is already pasted in, but it's the exact same code as what you'll see on Google's website. So at the top is the default, basically saying my capture device is going to be mic, my playback is going to be speaker, and then below it is, okay, so here's your mic. It's going to be a type plug, slave, with here you go. What we wrote down earlier was the A record, which is device 0, card 1, device 0. So in this case, it's HW, which stands for hardware, :1, 0. So we're going to go ahead and put that in here. And then for my speaker, same thing. We found that out through aplay-l. And as we noted before, that will be card 0, device 1. So go ahead and put that into your script. And then we're going to go ahead and save it. Next is the ALSA mixer. If you like, here you can play around with the sound settings of volume level if you like. With your volume properly adjusted, the next thing we want to do is test our sound. And you want to make a note to test the sound. You want to, okay, let's close this and open up a new session. You want to do speaker-test-t wave, and what's going to do is continuously play sound on the left speaker and the right speaker to make sure it's working properly. And to exile this, you just have to hold down Control and C at the same time. Okay, so mine was tested correctly. You're not going to hear what I have. This tutorial is just going to be a walkthrough. But assuming that works, you go into the next step, in which this case, I'm just going to hit the copy button here, and we're going to record a short audio clip. And you're going to paste it here. And then what it's going to do is it's going to record it in a format S16_LE for duration of 5 seconds at a rate of 16,000 hertz. File type is going to be raw, and then space out.raw is your file name. So as soon as you execute this, you can record a 5-second session audio recording, and it's going to put it in your Raspberry Pi home folder. So here, go ahead and just say something, anything you want. And then there, it's done. So let's go to the my Raspberry Pi home folder, and there it is, out.raw. All right, so now we're going to test our speaker. Let's do the next command, which is aplay. If you can just do the copy command here and paste it back into your command prompt. And the format and language and file name is already done for you, and you can play it. If successful, you should hear what you just recorded using the microphone should now be coming out of your speakers correctly. If not, you're going to need to pause here, troubleshoot a little bit, do some Google searches. Hopefully you don't have any issues, but if you do, the internet is your best friend to figure out what went wrong. It could have been either your USB port was not hooked up correctly, or there's something wrong with your device compatibility. Maybe the .asound.rc was not correctly loaded. So one of the quickest way to do it is to actually just restart your Raspberry Pi, or you can just look up a command to force Raspberry Pi to refresh your audio settings. So once you get everything working, we can go on to the next step, which is to click on Configure a Developer Project and Account Settings. So we want to go ahead and just click on the button to go to the Action Console. And this will take you to your Google's login page. Since I am already logged in, it just goes straight to the welcome screen. What you want to do here is scroll down a little bit and click on Add Import Project. You want to click on a field to enter a project name. And I'm going to call it My Assistant. After creating, we want to go back to the website and click on Enable API. Click on the top project selection. And if you don't see your project, click on the All tab, and then followed by clicking on My Assistant. And then we want to click on the very top, Enable APIs and Services. Okay, let's go back to the website, the Google developer website, and the next thing we want to click on is this little link here that says Activity Controls page. And you want to make sure your web activity, location, device information, basically just make sure everything is enabled. This is basically just for allowing Google Assistant to be able to access all the necessary information. And then we're going to click on the next step, which is register the device model. We're going to scroll down and click on Actions Console. We're going to click on Connected Properties. Select the Device Models tab and click on Register Model. So here we got to give our product a awesome product name, an awesome company name, and select the device type. So let's go ahead and pick something generic, and notice at the bottom of the screen Google is trying to make a unique name for you, so it added a lot of extra characters automatically. So here I'm going to do My Assistant and Botmation for my manufacturer, and device type we're just going to pick, let's see, of all the options they give me, I am going to go with, let's just call it a switch. And then once you're done, the next screen, it's basically saying you need to download credentials.json. And what this does is basically provides automatic credentials between your device and the Google server to know that you are referencing from your developer project. And that's how it keeps track of who you are and whether or not you have permissions to do what you need to do. So there's a couple ways to get this file over to your Raspberry Pi. One is the instructions below here on Google's website. The other is just if you're doing this directly on your Raspberry Pi, you just need to click on download. Once downloaded, you can go ahead and go to your file browser, find credentials.json, copy it, and where it needs to go is to home/pi. So let's go ahead and go there and paste it here. So once you're done with that, let's go back to the registration website and click on skip. And that's basically done with setting up your developer. And you need to now go to the bottom of the screen and click on the next thing, which is install the SDK and sample code. Here we are going to configure our Python virtual environment. This is just to keep everything isolated from all your other Python packages, just to basically put it in a sandbox for you to play with. So conveniently, Google also gave you everything you need to do here. You can just hit copy. That way you don't have to type these individually if you just copy the whole template here. Raspberry Pi will automatically run each command line automatically all the way to the end. So in this example, it'll be sudo apt-get, and then it's going to automatically go to the next command, and then the next command, all the way down, and it's going to end at source env bin activate, and it's going to wait for you to hit enter after that. So let's do this with a fresh command prompt, and paste it and hit enter. So notice that there is now a notation of env to the left of your Pi at Raspberry Pi. Basically, this indicates that you are now in a virtual environment within your Raspberry Pi. So here is where we'll install additional tools. So there are several packages you need to get. One is the port audio. So go ahead and copy and paste that code. And then next, we're going to get the latest Python packages. So same thing, we'll just copy here, paste it, and this is going to grab the latest Google Assistant library. So we're going to keep going down the list here. Next would be updating the credentials library as well. And then next, we're going to need to authorize our credentials with the Google servers. So let's go ahead and copy this code, paste it. And here it's trying to reference to that earlier file we downloaded called credentials.json. So we'll need to edit the path to the credentials.json. So let's go ahead and change that. Oh, sorry, I got that backwards. So let's change it to home/pi/credentials.json and hit enter. Okay, so now it pops up this massive link for you to click on. And what you need to do is copy it and paste it into the web browser. So you can select it and then copy it. And because I'm already signed in, you can just go ahead and select your account. And it's going to say, do you want to have this program access your project? And you say, sure. And here it is. Here's the key. You need to copy again and paste it back into your console. And now your program, or Raspberry Pi anyway, is now authorized using that credentials.json. So after authorization, then we now need to run our sample code. In this case, Google has a few options for you. There is a hot word sample that you could use. Or in our case, so what we're going to use is basically our push to talk, which is another sample library within this Google library. And you need to know your device model ID and project ID. And here I had it saved earlier and I put it in one of my text notes here. So I'm going ahead and copy this. I'm going to paste it. Okay, so if you go back to your Actions on Google website and click on Connected Properties, and then select your Devices Model tab. here you'll see your model ID. You're going to need to copy this down. Next, you'll want to go to your Google Assistant API website. This API website basically shows you all your statistics and of your project. So since you're running a freeware, you want to be aware that you're not going over the limits, where Google gives you basically a limit about how many connections or requests you can have in a given day. But it resets the next day. So you could potentially use this on a daily basis depending on how heavy you use this device. So to continue on, what we're going to do is click on My Assistant at the very top. It's going to show you a pop-up menu here, and here's your project ID. So you want to copy this and paste it into your project ID portion of your command prompt. So now we want to modify our command prompt command, which is Google-assistant-push to talk, which is the example library we want to run, followed by --device-model-id, followed by the super long model ID that was generated by Google. So what you copied down earlier, let's go ahead and put that there. And then it's followed by the project ID, which we got from the Google API website, which is a shorter version of your model ID. And if successful, you will get the code to run, and it's going to tell you to start saying something. And now at this point, you can basically practice on your own and see how you do. So the next portion is to modify the push-to-talk code. And the first thing you want to do is, let's go ahead and browse for it. It is located under py env lib python 3.4 site packages, Google samples, assistant, grpc, and then now finally we are at the folder where all this code is stored. So here I have several examples. You're not going to see the same screen of my earlier workings here, but when you run that command prompt code earlier, the push to talk command prompt command, it's going to launch this particular code right here, which is the push to talk.py. So let's go ahead and open this. So here, this is Google's sample code. And what I'm going to go through, I actually posted my code up at GitHub. So go ahead, if you don't have the link to my GitHub, it is posted on the description section of my video. It's going to be so much easier than trying to figure out where I injected code in the Google's versions of push-to-talk templates. So I recommend you take a pause if you don't already have it. Pause right here. Check out my main page, look for the GitHub accounts, and there should be a link to this push-to-talk Python code. And what you want to do is copy it and put it into the same folder. I would probably rename the original Google Assistant push-to-talk file and rename it to something like push-to-talk-original, so that you don't lose what was originally here. The original file is basically designed for you to run Google Assistant on Python, and what it's looking for is for you to click any key on the keyboard and it'll just continue. So basically simulating like if you had a device and you had to push a button in order to interact with Google Assistant, whereas the hot word Python file is just looking for you to say "Okay, Google," or one of the wake words. So here, let's go ahead and go through the code. The first section of the code is what Google originally had, which is a class for sample assistant object. And I inserted some code in here, which is basically just like LED indications Right here, you can see I commented a lot of the areas where I injected code. You can feel free to compare the original Google code. So here, I injected something called dim start equals 1, which basically, when in my video, if you see the LED starts dimming, which basically it's saying, I am now waiting for your request. So it's a visual indicator to you to say I should start requesting something, versus if you speak too early, Google wouldn't understand. So basically this just shows you when the program is actually in recording mode to start accepting your conversation. So anytime sooner than dimming, Google is not going to pick that up. So another thing to note with the dimming is that I had to include a threading library included into my Python. That way the code can simultaneously dim the LEDs at the same time while it's trying to listen to your requests. If you didn't put this in a separate thread and then you try to do a dimming, all it is going to do is just going to keep dimming and it's never going to listen to your request because the program can only do one thing at a time. And here in the once the Google Assistant understands your requests, I inserted a dim start equals 0, basically to stop dimming, to tell you that it heard you and it's now ready to respond. So that's kind of like a cool, real basic visual indicator of that that Google is interacting with you, and you're not trying to look at your Python code command prompt trying to see where Google is at. And if you just install a simple LED, this gives you really good simple feedback to you while you're troubleshooting or interacting with it on a daily basis. And then here's another section where I had to inject another code to stop Google's conversation stream. And the reason I did this is because I'm also using another conversation stream to use speech recognition. So if you don't pause one, then one of them will still have control over the microphone and the other one won't be able to hop onto it. So in order to fix that, you have to tell the Google Assistant to stop using the microphone in order to switch back to the speech recognition program, which the reason we have that is to create our own custom wake word commands. And then in the next section, the next class is the sample text assistant. This was taken from the text input assistant library, also from Google. The reason to have the sample text assistant in here is to play your own custom request into the Google Assistant, such as if you wanted to manipulate Google to do something simple as, hey, say, good morning Alex, you look great today, or hey, don't forget to do this, or did you, it's basically custom coding. So rather than having the Google Assistant where you just say hello and then it just waits for you to say something, I thought it would be interesting to have Google give you a custom, more personalized experience where you basically say, hello there Google, and then Google will then say, well, hello there Alex, what can I do for you today? So that's kind of how I did some of the examples in my other video of why Google didn't sound quite normal, is because I basically forced it using this library to basically tell it to repeat what I want it to repeat. And I can show you that a little bit in the later code. So in this section of the code, there's something I injected here, which is called a switchover. And that's basically just to, for your purposes, you probably don't need this unless you really wanted a multilingual Google Assistant. But if you just wanted a simple one language Google Assistant, you don't need the switchover setting. The switchover setting was basically just to have a custom response from Google when you switch over to a different language, from let's say English to German or to Japanese or to Korean and vice versa. But if you don't, this entire section probably is not needed, and you could probably just get away with just doing a custom greeting every time you launch Google. Then the next section is your main code, which is for the most part default from Google. I added a text input section. The text section is basically where I play the custom response from Google when you first initiate a different language or initiate a wake word. Then the next section is your speech recognition section. So the speech recognition section basically handles potentially your wake word, and it's just digesting what you're saying. And in my case, all I'm doing is a basic if-then statement just to look for the certain keywords that you're looking for. So it's not a fully developed wake word segment. It can definitely be developed or more refined into a actual wake word where it literally looks for that word only and then follow on by other commands. So in this case, I also am using GPIOs. Most likely you may not need this section depending on what you're trying to do as far as GPIO goes. So what you need to do is in here you have a lot of languages. So if you were to just look for a certain language, you could definitely just change out the wake word to something that you want. And I already coded in here the different language codes. So for example, in the first one you see English, and the language is set to new lang equals to en-us. So that tells Google later on that, hey, I want you to understand me in English. Follow on, if I did German, as you can see, there's one that says DE-DE. So that switches Google Assistant to German. And to do the custom text response, you see something here called uText query. So how I can get Google Assistant to say something custom, you could tell Google to repeat after me, and in this case, Botmation ready. Or in German, you can say yes, bot, and then imation in German. So it sounds like it's saying yes, Botmation in German. And the reason why I say in German is because I was trying to get Google to actually say that word in German, whereas if I had it actually translated in German and then played it in the German library, it was having some issues understanding that word. So that's why you see this kind of a weird implementation here. Feel free to expand upon it and hopefully use it for something that's more tailored to your own needs or wants. So in here, you're also going to see some additional language settings that wasn't in the video, such as Spanish neutral, which I found out doesn't really do anymore. It sounds exactly the same as Spanish, so that's why I didn't introduce it. There's also French Canadian, there's Australian, there's British, Canadian. So those were just Google in a different accent. So if you did Australian or British, and you carefully listen to Google's response, you can hear that there is a different tone to Google. So it's quite interesting. So as far as the Russian and Mandarin Chinese part, I was not able to find a API that actually did translations for speech recognition of Russian or Mandarin, as far as open source goes anyway. So what I did here is if you wanted Google to respond to you in a different language that's not in the official list, what you could do is have Google speak back to you in that language. So what I did was you speak to it in English, and then when it responds back, so that's why you see there's just switchovers settings equals 2 and 3 here, because I was trying to set it to a state where I understand what I'm trying to do. And so once you speak your request in English, it's going to respond back in English. But before it outputs into the audio speakers, that's why I have switchovers 2 and 3. I am going to intercept that message and then basically take that and then put it back into the text assistant. And I basically then tell the text assistant to take your previous response in English, but now tell it to me in Russian or Mandarin. And that's how you get Google to half speak or more like interact with Google halfly in that language. So you can probably still do additional languages that I haven't tried out yet that wasn't in this video. Feel free to try it, post it, show it to me. I'd love to see what you guys have done. Also just I like to see what else you guys do with this thing. And then more in the next section, I have something called the LED dim. So in this section, this is how I'm dimming the lights, but you have to run it in a separate thread. So what if you go back? Let's see. Yeah, so if you look at the previous other sections, that you'll see that there are dimming, and it'll run it in a separate thread so that Google Assistant can run simultaneously with the lights dimming on and off. And it's fairly simple. You basically set which pin number you are and then feed it into LED dim function, and it's just going to dim that one particular pin. And then at the end is the code to run all of this, which basically starts true. It's going to go into the speech function first, followed by main. And I added a couple code. Basically, if you were to run this permanently and you keep running into some issues from Google, which you might, because this whole project, even from Google, is still in the beta portion. So there's still a lot of kinks to work out. So if yours is getting some errors from Google and you're crashing a lot, what you can do is do what I did here. You can modify the encode to do a try, and then you're going to catch these errors using accept, and you're going to pass it, and then you're going to do an else, and you're going to break. And what's that going to do is, as you're getting these errors, your code is going to try to constantly just ignore it and then just keep restarting. And this should help keep your Google Home Assistant running a little longer, but it's still not perfect. So that's basically it. Feel free to help support my page by subscribing to my channel, share it, let me know how I'm doing. If you guys love these videos, let me know. I love to hear your comments and complaints. So let me know. Thanks for watching.